Let's continue on here. These I notice immediately, oh, my middle term is gone. I had an x4, the middle would have been an x squared, so it would have been an x4 0x squared minus 625, and then we would have canceled that out. So because I know the middle term is gone, whoops, I will create this, and I will put, I need them to be the same. So I could do x3 and an x1, because 3 plus 1 is 4, but I need to make them the same. So I'm going to make it an x squared and an x squared. Now 625, a bunch of things multiply to that, but I do know that 25 times 25 is 625. So those are the same, and then I make one of them negative. So if I do my diagonals, that's going to be x squared times negative 25 is a negative 25x squared, and that's going to be a positive 25x squared. And if you add them, you're going to get a 0x squared, and yeah, I do have 0 for the inside. So there's my factoring here. So x squared, actually maybe I'll move this here. So I have x squared plus 25 and x squared minus 25. So one of the things that I notice here when I'm doing all of these is I think to myself, hey, 16, that's a perfect number. That can be 4 times 4. Oh, 9's a perfect number, 3 times 3. 25 is perfect, 5 times 5. Oh, 25 is perfect, 5 times 5. 36 is perfect, 6 times 6. And so I notice those things, and so when I'm looking at this, I'll also be noticing, that it's a minus 16. It's a minus. This is a minus, it's a minus 25. Oh, this is a minus 36. Down here, minus 625. These ones, minus 16, minus 81. They're all minus. So one of the things you take a look at is the title. Now, the different word for minus is subtract or difference. So difference. And squares, those are our perfect squares. Like 16, that's 4 times 4. Or 81, that's 9 times 9. So we're looking at subtraction of these perfect square numbers. And so when I'm looking here, I see a subtraction and 625, which is a perfect number. But I also see that here. I see, hey, that's an x, 25 is 5 and 5, and it has a subtraction. So I'm going to try this. I'm going to make this a little bit larger. I can't do that for this one because it's not a subtraction. So 5 and negative 5. And if I do my diagonals, negative 5x and positive 5x, so negative 5x and positive 5x, that adds up to 0x, which is what I have here. That's my middle term. There is no x term in there. So what I actually have is this x plus 5 and x minus 5. That's my answer, kind of. So I have an x plus 5 and an x minus 5. That was me dealing with this. This still has to come down. That we didn't do anything with. So x squared plus 25. So I do have a question like this in the worksheet as well. It's like a double factoring question. And they're ones where you really have to pay attention to differences and perfect squares. So this might even, I don't know, maybe this will be one as well. I don't think so, but maybe it will. So I'm going to erase this. So let's try this here. 81, 9 and 9, x2 and x2, 16, well, that's be 4 and 4. I do notice then, so 16, perfect square, 81, perfect square, there's a minus sign in between. The y4s can both become y2s. The x4s can both become x2s. And so it should work. One's positive, this one's negative. So my diagonal here is going to be negative 36, x squared, y squared. This diagonal is going to be positive 36, negative 36, and positive 36 will be 0. So I'll write that down here. 9x squared plus 4y, and 9x squared minus 4y. So then I take a look at these. Oh, hey, 9's perfect, 4's perfect. These are squared. Oh, but there's an addition sign. So, okay, well, that one can't be done. But this one can. 9 is perfect, 3 and 3. The x squared can turn into an x and an x. 4 is a perfect number, 2 and 2. The y squared can turn into a y and a y. And there's a difference sign in between. So I'll make one positive, one negative. So this diagonal will be a negative 6xy and a positive 6xy. Those will cancel. That'll get me 0. So this again is a double factoring question. We have this can get carried down. This is the 9x squared plus 4y squared. But then we've got the 3x plus 2y and the 3x minus 2y. Okay? So that's good to keep all of these things in mind. Oh, this is probably another one. Okay, 625. This is x4. This is a y4. Okay, so 625. I know that's 25, and 25, perfect number. This can be an x2 and an x2. 81 is going to be 9 and 9. Y2 and a y2. One of them will have to be negative. Now, I don't know what 25 times 9 is, but whatever that is, this is also 25 times 9. So one will be negative, one will be positive, and it will cancel out. So I've got a 25x squared plus 9y squared, and a 25x squared minus 9y squared. Okay, so I see that minus. I see the 25 is a perfect number, 9 is a perfect number, x squared and y squared are both squared, so they can turn into single x's. So I'll do that. A 5 with a single x, 5 with a single x, 3 and 3 single y's, and they're both the same, and one's a negative. So this diagonal is negative 15, and that's positive 15, so it'll cancel out. So I'll bring that one down. So I've got a 25x squared plus 9y squared. And then I've got my 5x plus 3y that I just did, and then a 5x minus 3y. So all of these questions, 3 in a row here, are all double factoring questions, just for you to get the practice. So we have a little bit more to do with perfect squares, and we'll pick that up in the next video.